In this video, I explained the notion of Pareto efficiency and how it relates to some of the other ideas we've been talking about, specifically endowment economies. Now, Pareto efficiency is a very general concept, so I'm going to define it generally, and hopefully then we can talk about some specific examples. A situation is Pareto efficient if we can't make anyone better off without making anyone worse off. Another way to put this is that if we're in a Pareto efficient or Pareto optimal situation, if we're going to make someone better off, we're going to necessarily make some group or some individual worse off. So consider a very trite example. We have $100 to split among 100 different people. Let's consider situation A, where we give $99.01 to person 1 and 1 cent to every one of the other 99 people. You might object to this distribution of resources among individuals, but in order to make these 99 other people better off, we would have to, in this sort of contrived example, contrived world, we'd have to take some money from this first person. And to do that, we have to make person 1 worse off. And so we can't actually improve on this situation, and so this is going to be Pareto efficient. It doesn't mean that it's fair, but efficiency and fairness are different concepts. So let's consider a second example. In situation B, all 100 people get 99 cents, and then there's $1 that just goes to waste in the fury that goes over, in the fury of allocation, we tear it up, and no one gets to enjoy that extra dollar. This situation, we get $99 of total wealth allocated. There was a way to improve on that because we had $100 to allocate, and so we could get a Pareto improvement. And the situation B, is Pareto inefficient. And so the idea of Pareto efficiency is really useful for identifying clearly inefficient situations, where money is quite literally left on the table, where there are mutually beneficial trades that are not taking place. And so that's really a loose notion of efficiency. Here all we're asking is, we got to a situation, can we move from this situation to another one in a way that no one would vote against it? So now let's link this notion of Pareto efficiency to something that we've talked about in a previous video, the Edgeworth Box. For a review of the Edgeworth Box, all we've done is we've flipped the axis for person B. We've got person A here with his typical axis, and the total amount of good X is given by the width of the box, and the height of the box is the total amount of good Y. So we can think of each of these points in this Edgeworth box as an allocation of the endowment of X and Y to individuals A and B. And so we can think about how can we allocate this in a Pareto efficient way. So let's just consider a point and think about what must be the case for Pareto efficiency. Suppose that's our endowment point, and we're thinking about whether this endowment point is Pareto efficient. Well, we can ask ourselves, well, what bundles does person A prefer to E, and what bundles does person B prefer to E? This exercise is going to have us draw indifference curves through bundle E. Now let's say person A has an indifference curve that goes through E that looks like this blue indifference curve. It's convex to the origin, typical shape, and so that tells us that anything up here to the northeast of E is preferred by person A to bundle E. We can do a similar exercise for individual B. This indifference curve goes through bundle E for individual B, and it is convex to B's origin, which is up here. And so what we can see is that there's an intersection of bundles that these two individuals prefer to bundle E. So if they started out in a situation where E was being consumed, that would be Pareto inefficient. And the reason is that we can identify a situation that would be an improvement for both A and B. They would both vote for it. And so that improvement is right here in this I-shaped region. So to translate what we know about Pareto efficiency into the Edgeworth box means that whenever the indifference curves are not tangent, it is Pareto inefficient. So if we are to identify the set of points where we have a Pareto efficient outcome, we want to find the points where individual A and individual B have a tangency of their indifference curves. So O1 here is one such point. I've cleared the graph up of the previous indifference curves. I've just drawn a point that was potentially in that I-shaped region. And so you can see that we get a tangency there. And in this situation, if I propose any other point, I either have to make individual B worse off, or I have to make individual A worse off. And so O1 is Pareto efficient. Here at O2, we have a similar tangency between the indifference curve for B and the indifference curve for A. The notion of efficiency we have going on here is that if we start at OA, if we start at O2, a situation, we're evaluating this situation for whether it's efficient. If we start here at O2, can we make individual A and individual B better off starting from that point? And the answer here is no, because if we go above individual A's indifference curve, we make individual B worse off. If we go below to the southwest, we make individual B better off, but we make individual A worse off. And so when evaluating that allocation O2, it doesn't make the individual, we can't make both individuals better off moving from that point. And so you can see that we can get more than one Pareto efficient allocation in the Edgeworth box. In fact, we can get a whole bunch of them, and this is what's going to be called the Pareto set. And so you can see that this idea of Pareto efficiency, although it is a fairly straightforward idea, it's got some subtleties to it. In particular, we can't really say that O2 is more efficient than O1. All we can say is that both of them are efficient. We can't really assess which equilibrium or which allocation would be one that we would prefer over the other one. All we can say is that we're not wasting resources when we're looking at O1 versus O2. And to distinguish between this whole set of Pareto allocations, we would need to have a sharper characterization of how we feel about the equilibria. And this line is going to be a line of points that we would consider to be better than the other ones in the box, because if we're anywhere else, we're not going to be at a mutual tangency, and the individuals could make themselves better off by trading with one another.